Okay, so today we're talking about corresponding parts of congruent figures. Are congruent. Hold on, this isn't on. Give me a quick second. There we go. Alright, so you guys should have cut out two triangles. One of them is labeled ABC, the other one's labeled DEF. Does everybody have that done? Good. Alright, place the triangles next to each other on desktop. Since the triangles are congruent, there must be a sequence of rigid motions that maps ABC to DEF. Describe the sequence of rigid motions. How can you move one triangle to the next using a rigid motion to map it on itself? You could translate it. You could rotate it. And you could reflect it. Good job. Alright, the same sequence of rigid motions that maps ABC to DEF maps parts of ABC and DEF. So AB corresponds with what on this other triangle? DE. And I kind of like to look at it this way. You don't even need a triangle to see it. If AB is the first two in this triangle, then DE is the first two on that triangle. So using that same strategy, what would be congruent to BC? See how it says BC? What would be congruent over here? EF. And AC? Here's A and C would be D. Uh-oh. That would be helpful, huh? There we go. Thanks, Joe. Appreciate it. Okay. So, angle A corresponds with what angle? Let's go ahead and, so I'm sitting here talking about it and you guys are like, what is she talking about?
I'm like, maybe she's like, expecting him to think about it in her head or something.
Alright, so A, everybody look up here. So A corresponds with what? With D. See that? So A corresponds with D, B corresponds with what? E, and C corresponds with F. I'll give you guys a second to get out your books. Okay, so what does step C tell you about corresponding parts of the two triangles? If I know the triangles are congruent, what can I say about their corresponding parts? They're congruent as well. What do I mean by corresponding? Alex?
So when we have like two triangles or two congruent shapes, there will be parts that correspond or equivalent to each other. So, like for example, A and D would be corresponding angles.
So A corresponds with D.
And you can also have corresponding sides, corresponding shapes, as long as there's two sets there, one set of congruent shapes, and there's a corresponding.
These are corresponding parts. So how many corresponding parts would a triangle have?
That's more than 9 probably.
If you transpose things.
Well, you mean just by like angle-wise?
Angles and sides. How many corresponding parts would a triangle have to another triangle?
Oh, okay.
We would have 6. Good. You see what I'm trying to ask? Okay, if you know that triangle ABC is congruent with triangle DEF, what 6 congruent statements about segments and angles can you write? I can write angle A corresponds with angle D. I'm not sure why they're asking us to write this over again. Isn't this the same as this?
Yes.
Yes, let's not rewrite it. Alright, do your findings in this Explorer apply to figures other than triangles? For instance, if you know that these two quadrilaterals are congruent, how many corresponding parts would they have? How many? Why? 4 angles and 4 sides, so it would be 8. So 8 corresponding statements. I'm not going to write them all out. Give me one. Give me 1 out of the 8. Alex?
Angle L and angle R.
Angle L is congruent with angle R. L is congruent with R. Perfect. Questions so far? Pretty straightforward stuff, right? If they're congruent, the parts are congruent. All right, I will be able to use what I know about rigid motions to decide whether 2 figures are congruent. We know that rigid motions map onto congruent figures, correct? If I use a rigid motion, what's the only type of, what's a non-rigid motion that wouldn't be congruent? A dilation. Good. I'll be able to label congruent and non-congruent figures with a partner. That's what we will be doing today. All right, discussion. The triangles shown in the figure are congruent. Can you conclude that JK is congruent with QR? Well, let's label them first. So we have triangle. They should have had a congruency statement here, right? So triangle JKL is congruent with the triangle. You got to do it in order. Corresponding parts have to be congruent, so we better put the parts in the right order, right? So if I'm talking JKL, I know the R has to be in the middle, right? Well, which one should come first, the Q or the P? Q, R, P. How many congruency statements can I have based on these 2 congruent triangles? 6. So I would have angle J is congruent with which angle? Q. You can look at them right here, right? J and Q. What about angle K? Congruent with angle R. And what about angle L? Angle P. Oops, need the angle. All right, let's work with this. So if I know that triangle STU is congruent with triangle VWX, find the given side length or angle measure. All right, I want to talk something about measures. Angle measures. Okay, so see how this says the measure of angle S? First of all, tell me angle S is congruent with what angle? Just by looking up here. Good. Angle V. But this says the measure of angle S. Now here's a concept that I think a lot of students have a hard time with. Congruency versus equal. Means the same thing, right? If something's congruent, then it's equal. Okay, I used this in the last class and I think it worked really, really well. It's kind of like, well, first of all, what about these 2 desks right here? 7, sit up. So these 2 desks are congruent, but the size of the desks are equal. You see the difference? General statement. The desks themselves are congruent, but if I were to measure the top of that desk, their measures would be equal. It's kind of like a saw and a sock, right? Right? Aren't those 2 things the same thing? One of them is more formal than the other, right? The same type of thing. All right, so let's work with this. If I know that S is congruent with V, then I can say the measure of S is equal to the measure of V. You see the difference? Well, what is the measure of angle S? We don't know, right? We don't know the measure of angle S, but we do know the measure of angle V. How much is the measure of angle V? 38. So how much is the measure of angle S? 38 degrees. Let's do SU. I don't know the measure of SU, But I do know the measure of, let's see, SU corresponds with what? VX. What is the measure of VX? Here's VX, 43 feet. So SU must be 43 feet as well. Pretty easy? Okay, let's move on. Alright. I think I need this picture for the next slide. So I'm going to take a picture of it. You already have this one in your book, so we're not going to do it together. Let's go to the second one. Yeah. So I'll put my picture over here on the side. Okay, it says, I need to find the measure of angle D. So it tells me, since I know triangle ABC is congruent with DEF, then the measure of angle, okay, let's not skip steps, then that tells me angle what is congruent with angle D? If D is in the first place, then A is in the first place. That would be the one I'm looking at. So angle A is congruent with angle D, therefore the measure of angle A is equal to the measure of angle D. You see that technical little glitch in there, right? If the angles are congruent, then the measures of those angles are equal. It seems like a silly, unnecessary thing, but I want you guys to be able to recognize it, okay? It's like saying the same thing over again, right? All right, so write an equation. So do we know the measure of angle A? It's right here. See how it's pointing to it? What is the measure of angle A? 5y plus 11. What's the measure of angle D? 6y plus 2. If I subtract 5y from both sides, I would have no y on this side, and how many y's would I have on this side? 1y. If I subtract 2 from both sides, I would have y left, and how much would be left over? 9. We should have just done the math instead of filling in those boxes. I don't like when we have to fill in those boxes. So measure of angle D equals 6y plus 2. Well, we know what y is, so let's substitute. What is y? 9. So 6 times 9 is 54. Add 2. 56. What if I did 5y plus 11? What would that equal? Same thing, right? 5 times 9 plus 11. 45 plus 11 is 45 plus 11, 56. So we must be right, correct? All right, your turn. You guys do LM and measure of angle H for me. All right, let's see what you got.
What?
So LM. Here's LM. What's LM going to correspond with? GH. Do I know GH? I do. GH is 4x plus 3. I should probably write it on the other side. Right? It should go over here because LM is equal to GH. Does it tell me what LM is? LM is 6x minus 13. Okay, how would I solve this? Add 13 to both sides, and what else could I do at the same time? Minus 4x from both sides. Hey, what property am I using when I do that? Do you remember? Do you guys remember that property? It's a property of equality. It's a PO. Nobody? It's the addition property of equality. I can add the same thing to both sides? All right, what's left over? Let's see. 6x minus 4x is 2x equals 16. If 2x is equal to 16, how much does 1x equal? Are we done? We found 8.
You gotta plug it in.
We've got to substitute. It told me to find LM. Well, I know LM. I know LM is 6x minus 13. And I know what 8 is. So I just need to substitute x for 8. What is 48 minus 13? What's 48 minus 10? 38 minus 3?
35.
35. Finding the measure of angle H will be the same thing? We're going to move on. All right, pencils down. You've got this one in your book. So, pencils down, heads up, eyes up here. Okay, so we're going to start proofs off nice and easy. Already? We're already complaining we haven't even started. All right, write each proof. Okay, so they're going to give me a statement and they're going to ask me to prove something. And we've just got to go in logical sequence. Okay? So, if it tells me that I have triangle ABD, which is right here. Let me change my color here. A, B, D is congruent with ACD. Is congruent with ACD. We just learned a whole bunch about that, right? We learned that if ABD is congruent with ACD, I've got 6 congruency statements I could say from that, right? Alex? Oh. Yeah, just let me go with this. Okay. So I've got 6 congruency statements I could say. Whenever they give me something, it's a clue for what's coming next. All right. So the first one, so my first statement is exactly what they gave me, and that's why we call it the given. Second statement, first of all, let's look at what we have to prove. We need to prove that D is the midpoint of BC. Wants me to prove that this point right here is the midpoint of this entire segment. Well, if it's the middle, what do I know about these two? That their measures are equal or that they're congruent, right? Well, doesn't that take me back to, yeah, I know that they're congruent because the whole triangles are congruent, right? So I just worked my way backwards. So if they give me that the triangles are congruent, I know I'm going to have to make some type of congruency statement. So I say that BD is congruent with CD. I know that because corresponding parts of congruent figures are congruent. That's what we learned today, right? Since I know that they're congruent, their measures are equal. If their measures are equal, then D must be the midpoint. We know that because we know the definition of midpoint means that the measures are equal. All right, let's do one together. So this is kind of what you're going to see on your test on Thursday. So don't freak out. We're easing you into proofs. You'll get all the statements, and you'll have to tell me the reason. So let's follow this along. Given quadrilateral JKLM is congruent with quadrilateral NPQR. So that's my first statement. What's my reason? Given. There's another given here, though. They also told me that J is congruent with K. First of all, because they just told me that these two quadrilaterals are congruent, what is J congruent with? Here's J. What's J congruent with? Right here. N. This is the first one. This is the first one. So J is congruent with N. I know that based on what they told me, right? They also told me that J is congruent with K. Okay, this is a big clue. Whenever they give you a statement and then give you an extra piece of information, it means that there's a middleman going on here. So J is congruent with K is also a given, correct? The next statement they say is K is congruent with P. How do I know K is congruent with P? So here's J, here's K, and here's P. I heard Alex say it. How do I know that K and P are congruent? Corresponding part of congruent figures are congruent. You can shorten it like that. All right, now this is what I'm talking about, the middleman. It told me that J and K are equal. I know that it wants me to prove J and P. Here's J and P right here. Well, let's look at J and P. What do I know P is congruent with? So see this? J is congruent with K. K is congruent with P. Therefore, I must know that J is congruent with P. Do you see this middleman right here?
Yeah.
Do you know what property tells me that that's true? They're basically the same thing, right? It's the transitive property. Transferring one piece of information to the other, right? Transitive. Kind of like if I know Joe is the same age as Caitlin and Caitlin is the same age as Paul, then Joe must be the same age as Paul, right? Crazy. Not too bad, right? Let's try one more.
Do it.
We have a minute. All right. Proven given SVT is congruent with triangle SWC.
I don't think we had a minute.
We didn't have a minute. All right, guys. Have a good day. Okay, I'm going to finish up the recording. So if I know triangle SVT is congruent with SWT, let's see. Let me just use highlighting. SV, wrong highlighter. So SVT is congruent with SWT. So there's my statement. My reason is that's what they've given me. I want to prove that ST bisects VSW. So this big angle right here is being bisected by ST. Change the color of that. Well, if I work my logic backwards, ST bisects if this angle is congruent with this angle. Well, I can say that angle is congruent with that angle because VST has to be congruent with WST. I know that because corresponding parts of congruent figures are congruent. Congruent figures are congruent. So angle VST is congruent with angle. VST is congruent with WST. WST. So if that angle is congruent with that angle, then I know that ST bisects angle VSW because of the definition of an angle bisector. Definition of angle bisector. And we're done.